Okay, so we're going to learn how to handle particulate solids. Okay, so in this chapter, we're going to study the characterization of solid particles. And if you ask why we need characterization of solid particles, let me give you one example. So let me ask you, what is the shape of this, you know, uh, this 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 object? You will say circle, right? In 3D, it will be sphere. Okay. What is the shape of this called? Suppose this is a particle. What is the shape? This is cube, right? This was sphere. Okay. What is the shape of this thing? This is cylinder, right? So you know the this if I have a particle of this shape, then it is cube, and this is this sphere. Okay. What if I have this? So what is the shape of this particle? Clearly you cannot say it, right? Yes, that's the problem. So the definition of shape is not clear, right? So we have to define one number so that we can say the shape of this is this, right? So we have to define something clearly. Okay, so that is the purpose of this topic. So delete this. So to characterize a particle, right, we need its size, sorry, size and shape. Okay, to characterize a particle. Okay, we need to define size of that particle and shape. Okay, for irregular objects as well. So we should have some, terms or constants to define the size and shape of irregular objects as well, or particles as well, right? So we'll learn about it. And if you ask, why do you need to, characterize? We need to characterize the particles because suppose you are doing crushing, you have a rock, right? You have crushed it. Then if you crush the rock, then it will be, broken into smaller irregular pieces. Now, what is the shape of this irregular particle? Right? You cannot say, right? So we have to define something. So define the diameter or what the size, and how we can say it is, how can we define the shape of this particle? Okay. So to do that, we will define a term called sphericity. So sphericity. Okay. So it is denoted by phi s. Okay. So this is called sphericity. How it is defined? So sphericity is equal to surface of particle, surface of sphere, surface by volume ratio of sphere by surface by volume ratio of the particle. You are going to define the sphericity for a particle. Suppose you have this irregular shape particle, right? So let's say you know the surface area of this particle, you know the SP, and you know the volume of the particle. Let's say you know the density of this particle, so you can easily calculate the volume from mass and mass, right? And what about this sphere? Suppose this volume, I mean, what is this is this surface area of a sphere divided by volume of the sphere. What is this volume? This volume is equal to the volume of this particle, okay? If this particle, if this particle has a volume something V, and if I take this volume and try to shape it into a sphere, so what will be the diameter of that sphere? I mean that particle. Okay. So this is the definition of sphericity. So if we move down, we can see it. We have a PDF here. Okay. So here, this is the see. This is the definition of sphericity. So what is so what is SP, surface area of one particle? What is BP, volume of one particle? dP is equivalent diameter or nominal diameter of the particle. Okay. So I told you this was phi s is equal to SP by VP of sphere, okay, sphere, and SP by VP of the particle you are going to define the sphericity for. Okay, let's go quickly how this formula has arrived from this general definition. Okay, so let's first calculate this term. What is SP? What is the surface area of a sphere of diameter d? What is that? So it is 4 pi r square, right, in terms of radius. What is the volume of the sphere? 4 by 3 pi r cube. Now if you calculate this, you'll get what? 4 pi cancels out, 3 goes up, 3 by r, right? And r is nothing but d by 2. So you have 3 by diameter by 2. So this gives you 6 by dp. Okay. Here you got here 6 by dp. For in this case it is 6 by dp. Okay. What is dp? dp is the equivalent diameter for this irregular particle. Let's just we have something called equivalent diameter. So that is the dp here. Okay. And now for the particle, you can calculate, let's say you know the surface area of that one particle and volume of that particle by using some measurements. So you can calculate the sphericity. Okay. So the basic quick formula is for sphericity calculation is phi s is equal to 6 by dp. This is the equivalent diameter, and sp by vp of that particle whose sphericity we are going to calculate. Okay. Now let's go through some examples, then only you will understand. Okay. Let's try to calculate the sphericity of a cube. So what is the sphericity of cube? You know the shape of a cube is something like this, right? let's say it is of length L. Right? Let's give it as if I assume this cube as a sphere, then what would be the diameter, equivalent diameter? So let's say D. Assume that this L is some dp. Okay. Now let's calculate the sphericity. So according to definition, we have phi s is equal to 6 by dp. Right? dp here, the edge length of the side of the cube, so that is L, or you can say dp. You can put also L here, no issue. Let's put L here. You can take L or dp because this will be the equivalent diameter if you assume this as a spherical particle. Okay. Now calculate Sp by Vp of the cube. Okay, what will the answer? So what is the surface area of this cube? We have 6 faces and each face has a area of L square, right? So 6 into L square or 6 into dp square, right? And what is the volume of the cube? We have L cube, or you can say dp cube. Okay, if you simplify this, you have 6 by dp, right? Now you just put here, you have Sp by Vp, right, for the particle, that is cube here, cube particle, single cube particle. So instead of L, you just assume it's dp. So 6 by dp. What is the value of Sp by Vp? It is 6 by dp. The whole thing cancels out, so you get 1, right? So sphericity of cube is 1. So it is sphericity of cube is 1. What do you mean by that, right? What do you mean by the sphericity of cube is 1? It means the cube is almost similar to sphere, right? It is almost similar to the sphere. You can take cube, assume cube as a particle of spherical shape. Okay. Let's try to find out. I mean, the shape of the cube is almost uh, same as sphere. It has a close relation with sphere. Okay, we'll solve one more problem. So let's try to calculate sphericity of what? You want to calculate the sphericity of sphere. What is the sphericity of sphere? So it is, what is the formula? Sp by Vp, which is already that 6 by dp was there. So I'll skip that. So 6 by dp into Sp by Vp of sphere, right? We want to calculate the sphericity of a sphere. So it will definitely be 6 by dp. Again, Sp by Vp of sphere will be 6 by dp. So it is 1. So the sphere looks like sphere, right? The sphere is exactly a sphere, so that's why sphericity is 1. Sphericity means if irregular particle, how closely the irregular particle resembles to the sphere. So in case of cube, we already discussed that the cube can be considered as close two spheres, right? Because that's why it has a sphericity of 1. Suppose you have a particle like this. Can you guess the value of sphericity for this particle? So this sphericity of this irregular particle will be away from 1. It will not be 1. It will be somewhere maybe less than here. Let's say this is 0.5 in the midway, so it will be somewhere here, because it is in no way it looks like a sphere. Okay, if this particle looks like exactly like sphere, then this sphericity will be 1. If it doesn't look like a sphere at all, then it will be 0. And if it has some similarity like a sphere, then it will have in between 0 and 1. Okay, that's the meaning of sphericity. Let's delete all this stuff. Okay, let's calculate the sphericity of a cylinder, solid cylinder. Okay, this is your cylinder. Let's say the diameter is dp. Again, the length is also dp. Okay, this is solid cylinder where diameter is equal to your length, and both, let's say, give a name dp. Okay, let's try to calculate the sphericity of a solid cylinder now. So by definition, sphericity of that solid cylinder will be, you have already 6 by dp and sp by vp of that solid cylinder. Okay, so what is this value? So the surface area of a cylinder, you have to consider this circular cross sections as well, and the curve one. So you have, in terms of diameter, so what is this? Pi d square by 4 n multiplied by 2, right? So n plus n this curved surface. So what is the surface area of this curved one? So that is pi d. So you have to first calculate the circumference, that is pi d, into the height, length. So that is your d again. So it is nothing but pi, sorry. So this was 2 plus pi d, that is perimeter, into length. So it is nothing but pi d square. So if you simplify it, then you will get something like 3 pi d square by 2. Okay, that is your surface area. So that's, we have already calculated it. Okay, so you have found out the value of sp by sp, right? Pi dp square. Okay, what is the volume of the solid cylinder? It is nothing but the cross section area into diameter, right? So what will be that? So this is nothing but, we will be having cube. Okay, just divide these two. So what you will get? 2 pi cancels out. This becomes single dp. Okay, so you're basically getting 6 by dp. So you get 6 by dp. If you put this in here, then you will get sphericity 1. That means the solid cylinder can be treated as, it has almost same shape like a sphere. This is the meaning of sphericity. Okay.